Testing. All right. Good morning, good afternoon. I think we'll go ahead and kick off the webinar. Just a few housekeeping items. Thank you for all the attendees for joining us today. The session will be recorded and it will be provided to the attendees and whoever has missed the session. So thank you all again for being with us. At any time during the webinar, please go to the Q&A section of the webinar and please type your question and it will be addressed in the last 15 to 20 minutes of today. So again, thank you all for being here. Please type your questions at any time in the Q&A section and let's go ahead and get started. It's really a pleasure to be here today hosting this webinar. This is Mo Abu Ali. I'm a managing partner at IoT company and I'm here with the Predictronics team and our client and partner MacLean-Fogg. So I appreciate everybody being here with us today, sharing their experiences on predictive maintenance and a webinar on the topic of a day in the life of a predictive maintenance team. And we truly do have a predictive maintenance and a manufacturing team here with us today. We have Roman Totten, manufacturing engineer at MacLean-Fogg. Roman, welcome.
Good afternoon.
Thank you for being with us today. We have John Delk, Director of Continuous Improvement at Medform. John, good afternoon.
Good afternoon. Thanks for having us.
Thank you. And we have Steve Wright, General Manager at Medform. Steve, thanks for being with us.
Yep. Hello, everyone.
And I'm here joined by Dr. David Siegel, Chief Technology Officer of Predictronics. David, good afternoon.
Yeah, good afternoon to everyone.
Thank you all very much for being here with us today to share your experiences on how you're using predictive analytics and predictive maintenance on your factory floor. So let's go ahead and get started. I'll go ahead and give a few introductory slides on the market and what we see around Industry 4.0 and predictive analytics. Then my colleague, David Siegel, will go through the technology and the value of predictive analytics. And with this brief introduction, we'll hand it to the MacLean-Fogg team to kind of guide us through the journey and the case study of implementing predictive solutions on their factory floor. So let's get started. So you might be hearing a lot of names. You might hear about IoT. You might be hearing about IIoT. You might be hearing about Industry 4.0. So just to clear some of the nomenclature that you might be hearing in this presentation, the field of IoT or Internet of Things is by no means a new field. It is maybe a new naming, but Internet of Things is all about connectivity, data acquisition, and delivering value using cloud and analytics to all industries, all things, all devices. You might have a Google Nest at home and your Google Nest is connected via the internet to your cell phone. You're able to, control the temperature and get energy savings in your house, in your home, or in your business by using such an IoT device. But in the manufacturing sector, which is the industrial Internet of Things within industry, a factory has multiple layers of what we call the ISA 95 or automation pyramid. You have machines, you have CNCs, PLCs, you have sensors. In some areas, you have data acquisition or SCADA systems. In some plants, you have manufacturing execution systems that are marrying the shop floor with the top floor, which is your enterprise resource planning, business, or finance systems. So Industry 4.0 or the fourth industrial revolution addresses many challenges and mitigates many risks that are facing manufacturers today to kind of converge the IT layer, the information technology layer, and the shop floor, the OT layer, or the operational technology layer. Industry 4.0 really marries the best practices of traditional manufacturing and the technological world. And understanding that different manufacturers have different levels of digital maturity it's important to really align the company's or any company's overall strategy with not just technology, but also people and process, right? So we believe when we partner with organizations that having a digital roadmap or an analytics roadmap is very important. And you'll see the MacLean-Fogg team and their manufacturing 4.0 roadmap. But very high level speaking, and actually starting from the right and going backwards, the ROI is key. It is very important to think ROI first and foremost and have a very clear business case of implementing these types of solutions on the factory floor. Followed by an understanding of where to implement this type of technology. It's important to implement it on critical assets. It's important to get connected and to capture real-time data from the factory floor, and then to bring that data into analytic solutions that are able to contextualize the data and convert that data, that big data, to smarter data so that manufacturers can use it to drive improvements on their factory floor. And last but not least, it's important to have a think big, start small mentality. It's important to select and adopt and scale the right technologies that make sense for that business case and for the application in hand. So IoT, industrial IoT and industry 4.0 are really upon us. And to be competitive in an increasingly competitive market space in manufacturing, it's important to start considering and investing in these types of technologies. So one of those technologies, one of the key tools, essential tools for Industry 4.0 today is predictive analytics, or specifically in this presentation is predictive maintenance. And what you see here is a recent research actually that shows a significant market opportunity around and growth around predictive maintenance. Manufacturers are seeing value and are investing and are driving improvements today using predictive maintenance. It is forecasted that there's almost a 30% annual global market growth in predictive maintenance today, with a significant valuation, almost an exponential trend in the next 5 to 6 years. So investments are key in this types of technology, and predictive maintenance has become one of the key drivers and applications for Industry 4.0 today. So what trends are out there? From a regional or a geographical perspective, North America actually, specifically United States primarily, is the largest market share today in terms of deployment and adoption of predictive maintenance solutions, making up almost 30%. However, there is a growth potential accelerating in Asia. How about the sectors? Well, manufacturing actually holds the largest market share in implementing predictive solutions in a variety of critical types of industries and a variety of critical asset types, including robotics, casting, machining, and so on. How is it deployed? Well, at the moment, the cloud is definitely gaining share. But most deployments are implemented on-premise. A majority, almost 60% of implementations of predictive maintenance are implemented on-premise today. But there's definitely a growth in cloud implementations on a global scale. And last but not least, and actually the application that you'll be witnessing today is focused around vibration-based analytics. We understand that there's a variety of predictive maintenance techniques out there, including thermography, fluid analysis, and so on and so forth. But surely vibration monitoring is at the top of that list. It is holding the largest market share today, yet other techniques are still noteworthy. And last but not least, it's always important to start with the business case. We like to say ROI first and foremost. When we talk about predictive analytics and we talk about smart manufacturing, we're driving manufacturers toward a vision of zero downtime, zero waste, or zero defect operation. And in order to do that, an understanding of the business case and connectivity and analytics need to be implemented in a systematic way and to have a clear business case behind it. What you see here is a survey of some of our clientele in the past years and some of the gains they have seen by adopting these types of technologies. OEE being a key metric, overall equipment effectiveness, and specifically when it comes to predictive maintenance, it is improving and sustaining uptime gains within the plant. But nevertheless, there is also opportunities to tie these predictive maintenance systems into the CMMS, the maintenance systems, or the engineering asset management systems that you might be running, SAP, Infor, Oracle, whatever that might be, because you can send predictive insights into those systems and order spare parts in a more predictive fashion. You can optimize preventive maintenance schedules in a more elaborate way. You can eliminate overhead maintenance and shift the operation from a reactive mode to a predictive and preventive and even prescriptive mode of doing maintenance. Therefore, not only impacting OEE, but impacting your mean time between failure, your mean time to repair, and labor and scheduling of your maintenance resources. What we will not discuss today, but it will be a subject of a future webinar, is predictive quality, is actually correlating machine and process data with quality of the products and the batches and the lots that are being produced, and being prescriptive in detecting and predicting scrap that might be produced on the machine, due to process parameter deviation and maintenance issue on the machine. So it is a natural extension of implementing predictive maintenance. So the message here is adoption is growing for predictive analytics. The ROI use case is there when it's implemented on the critical assets. And you will witness that today in the conversation with the MacLean-Fogg team. But before we do that, I'd love my colleague, David Siegel, to say a few words about the technology and the value of the technology and kind of set the stage for the MacLean-Fogg presentation. David,
yeah.
I'll hand it to you.
Yeah, thank you, Mo, for the introduction, especially your perspective on the industry trends as well as the business case. And to get a little bit more into the technology side, if you're looking at predictive solutions for an Industry 4.0 initiative or a smart factory type of initiative, these are three general categories. The one that we'll go into a little bit deeper in terms of a use case with our friends at MacLean-Fogg is on the topic of predictive maintenance. And really here you're replacing the traditional reactive or preventative maintenance approaches, which are more based on a timed and scheduled maintenance, with the use of sensors, IoT, and advanced analytics and machine learning algorithms to make sense of all that data and ultimately achieve better maintenance practices, a reduction in unplanned downtime, and improvements in productivity. There are other use cases for the smart factory. Mo was alluding to the concept of predictive quality, which is relating all your process parameters to quality metrics, again, with the goal of reducing scrap and improving quality and productivity. And again, you would also use IoT, connectivity, sensors, as well as machine learning based analytics to make sense of all that data. And then the third category is really more advanced process monitoring. So looking at all the data that you're collecting from your manufacturing process, and also trying to make more sense of it, find hidden trends and patterns and all that data, and ultimately present a better visualization of that data. So those are the three popular use cases for the smart factory. Next. And if you look at the approach to building these predictive systems using machine learning and artificial intelligence, these are the six pillars or blocks. You start out by looking at what data you need to collect and setting up the data collection system, which includes data from maybe controllers, like using protocols like OPC UA or MT Connect, as well as adding additional instrumentation as needed, and combining those different data sources together with the appropriate triggering and sampling rate, so you have good quality data, so you can ultimately make better decisions about your machine and processes. From there, the next steps are more the analytic steps. So signal processing involves filtering, finding patterns in the data, and then the feature extraction is finding those symptoms or those metrics that are related to the health of the machine, and then you would track those over time and use the machine learning to compare those to reference conditions, usually initially a baseline condition, and you'd be tracking those changes to the baseline over time. And then as you have an assessment of the machine or process health over time, you can then take additional steps for diagnosis and prediction as needed. So in terms of the technology, the software that we're using was developed for these smart factory use cases, in particular predictive maintenance and predictive quality. And the general idea is to take all this data and reduce the guesswork and reduce some of the concerns in terms of equipment reliability, performance of the machines and process, the health of the equipment, and so on, and to take that guesswork out of it and use the power of machine learning and predictive analytics to make sense of all that data, ultimately to again improve the maintenance of the manufacturing and shop floor, improve the productivity, reduce unplanned downtime, and so on. And going back to what Mo mentioned earlier about the business case being really important, and it's really key to have this business case in place before you go down your journey and select your particular use case for deploying this technology. This is an example business case and return on investment. This is for an automotive manufacturer that we worked with before, and their use case was they had all these robots doing material handling and welding for making these various automotive parts, and for them downtime was very expensive. 1 minute of downtime for them may be $10,000, and based on their past historical maintenance records before the project had started, they had 30 robot failures during production. So if you just predict and prevent even just 50% of these with a predictive maintenance type of solution, you're looking at millions of dollars savings per year. And this just shows you one example return on investment or business case. And you would like to do a similar calculation for the use cases that you're considering, and even rank several to make the initial selection of where you want to deploy the technology first and move it forward. So with that in mind, I'll pass it off to MacLean-Fogg to talk about more of their journey and their use case.
Thank you very much, David, for your insights. And just a very brief reminder for the audience today, if you have any questions whatsoever during the presentation, please don't hesitate to write it in the Q&A section of the webinar. Thank you. Again, a big welcome to the MacLean-Fogg team. Steve, John, and Roman, thank you for being with us. We'd like to first start with an introductory video on MacLean-Fogg. This is MacLean-Fogg.
Since 1976, Metform has been a leading manufacturer in northwestern Illinois, supplying parts and solutions to the automotive and heavy truck industry. Each day, we continue to build a thriving culture of teamwork, innovation, and opportunity. Metform is a division of MacLean-Fogg, a fourth-generation family-owned manufacturing company with a track record of success, stability, and strong family values. We know people are our greatest asset, and a respectful and safe work environment is never compromised.
Thank you. Steve Wright, good afternoon. Thanks for being with us.
All right. Good afternoon, everyone. I'm Steve Wright. I'm the general manager at Metform, and I think the video just kind of explained that Metform is a division of MacLean-Fogg. John will talk more about that in the next segment. I wanted to talk about the critical objective of this project for us. For those that don't know us, hot forging is core to our business. We have 10 Hatteber hot forming presses, I think the largest fleet in North America. The largest of those machines is an AMP-50, and we only have one of those. We produce parts for Chrysler, ZF, and other major OEMs. We installed the machine in 2012, and we've had 3 kind of major unplanned maintenance events on this machine that, being the only machine we have and being an automotive supply company, you can't have that. And you can imagine the anxiety that created for our customers. We have a good preventive maintenance system in place, I think, but we recognized we needed a better predictive maintenance system. So we partnered with IoTco to use Predictronics. John and Roman will walk you through that in more detail. But for me, I'd say as a general manager, I like what I see so far. We're able to monitor the machine health and see real time how the machine is doing, start to see a signal of a problem before it becomes a major problem. We have a long ways to go in terms of learning how to better utilize the system and gain confidence in the system. But at this point in time, I'm really pleased with the progress we made. And as John knows, I'm anxious to expand this to the other 9 Hatterverse. So with that, I'll turn it over to John Delk.
Okay, thank you, Steve. Looking at the slide, we've got showing some of the products that we provide to our customers. On the left, you see some SecureX wheel nuts, which go to heavy truck and trailer. You see some gear blanks that we provide to automotive, and then some various special fasteners and special form parts that kind of represents the types of parts that we produce. The processes that we follow are basically our hot forming, followed by heat treat process, and then we do some secondary operations to clean up the parts, and then finally machining before they ship to the customer. But as we discussed, the hot forming process is really the kind of the backbone of our business. And on the next slide, just to give a little bit of context to the process, we're basically taking steel bar, heating it up above the transformation stage to 200 or 2,250 degrees Fahrenheit. A blank is cut off. It is then moved to the next station where it is pressed via a punch and die set into a basic form. We add some contour in the second station, and then finally there's a knockout of a hole in the center in the third station. This process is happening at a rate of about 75 to 80 strokes a minute. So the machine is moving pretty fast, and as I highlighted, the parts are pretty hot. So moving on to the next slide, which kind of sets the foundation for our work. At MacLean-Fogg, we developed a digital transformation strategy, and these were some of the key elements that we wanted to have, and they dovetailed very much with, as Mo and David described, how we had set things up. We definitely wanted to define the business need for this project. We had an ROI of less than 2 years. By starting small, we wanted to focus on our most critical asset and just that one asset. And as we were developing this project and where we wanted to go, we set our roadmap for the various areas of the business. And as you'll see in the next slide, that we mapped that out over several years. Some of the key elements in terms of building our roadmap, we recognized that there was going to be a cultural change within the business as to how we were looking at maintenance, very well established with our preventative maintenance process, but wanted to take it to the next level to get to predictive maintenance. And so we also recognize the importance of building some partnerships within our team and with our external partners, including IoTco and Predictronics. We learned very early on that it was important to be open, to make sure we were getting good feedback from the team, and then to be flexible with the things that we were learning. So jumping to the next slide, you see just a snip from our roadmap. We really had it organized by the categories of Industry 4.0. Wanted to focus again on where is the benefit to the business. We've got some timelines as to where we wanted to take which steps and ultimately set the destination where we wanted to go in our future state. But if we move on to the next slide, we'll talk a little bit more about the project in particular. Our biggest opportunity was with our AMP50 hot former. Again, most important asset within our business. Setting the baseline, we have a team of seasoned operators and have added some new team members along the way. We have a very strong maintenance team and a very good preventative maintenance program in place. And we've had good relationships with our OEM of Hatterberg, the equipment manufacturer, and with our outside support teams that help us when we have challenges. we recognized the need to look at what was our, our downtime, trying to improve the number of pieces that we can get off of that asset, and make sure that we're avoiding critical, downtime that would affect our ability to deliver to our customers. We wanted to focus on the drivetrain of the AMP50, since that was probably the area where we saw the biggest opportunity within the asset. Some of the challenges that we met from a data collection standpoint, there's a lot of spreadsheets, a lot of handwritten notes, a lot of tribal knowledge. And so we wanted to make sure that we could gather that information and put it into context as we were analyzing the equipment. And we recognized that there was a gap in the data that we had. We had some good information off of the machine in terms of how it's performing, data that was captured within the PLC, but we needed to make sure that we were providing that data to the right team members at the right time, so that the operators were getting information, so that our maintenance team was getting good information, and that our leadership was getting good information on what our next steps might need to be. We recognized that there was a gap in instrumentation. So as a team, we worked together on sensor selection to make sure that we were getting good data from the machine to put the other pieces of data that we had into context for how the machine was performing. So as a team, we decided on 4 collection points around the drivetrain, and we went with 3-axis vibration sensors. So moving on to the next slide. I'll let the Predictronics team provide a little color of the PDX solution.
Yes, thank you, John. And to give you a little bit more background about the underlying technology that was used for this predictive maintenance use case, we're using the PDX software, which was developed primarily for these Industry 4.0 and smart factory types of applications, including predictive maintenance. So the software has modules for data collection and connectivity, because collecting good quality data is the foundation for making better decisions about your machine health and equipment. And it also includes modules for analyzing all this data. It's a combination of pre-processing techniques, extracting metrics or features from the data, as well as machine learning. And that configuration is then sent to our deploy software, which runs all these calculations, for example, on an on-premise server, and presents the results on a dashboard that you see here. So these are actual screenshots from the deployed solution. And the MacLean-Fogg will show you an example of the health monitoring results for one of their machines, or one of their sections of the machine that we're monitoring. So in terms of the architecture for how the solution was configured, we start with the machine layer, and we look at what data we can collect, which includes sensors that may be already there for the control of the machine. So this can include using protocols like OPC-UA to collect various tags related to the machine, whether it be tonnage or maybe the stroke rate of the machine and so on. In addition, we looked at adding additional instrumentation to the machine, such as vibration at various locations. I believe we ended up selecting 4 tri-axis accelerometers to monitor the condition of the machine. In addition, with that in mind, we would use our data collection software to aggregate all this data, send that data to the on-premise server, where the more in-depth analytics could be run, including the machine learning, to make sense of all those patterns. And those results can then be displayed on a dashboard, as well as presented to the end user. So I'll hand it over to maybe Roman to give a little bit more specifics about the actual sensor selection and installation, including the vibration sensors that were picked out.
Thank you, David. Yeah, so as David mentioned, I think kind of one of the biggest aspects to this project was kind of identifying the vibration sensors and what to do with them, where to put them. So the actual recommendation came originally from Predictronics, And then with some discussions internally between our team that is both heavily involved with the machine, as long as the machine builder, and then also a partner between Hatteber and ourselves, FES, Forging Equipment Solutions. You know, we've had a couple of discussions on do we want single axle, triaxial, and positions on where we put them. And honestly, discussions got into the fact of not even general areas, but on which bearing caps, you know, what would be best to, where would be best to put the sensor without possibly causing any kind of additional stress or anything on the machine. So we were very heavily involved with the builders in determining a lot of this information as well. But ultimately, due to some of the failures, as Steve Wright has mentioned, and where some of those failures might have occurred, we have decided that it was best to go with triaxial to get all three ranges of motion for the shafts that we were monitoring. And then they are spread out and touch nearly all the main shafts within the main drivetrain on that machine. So, and then I will go ahead and kick it over to John. You can kind of talk about our dashboard a little bit.
So the data you see is off of our AMP50. And to put some context to the data, every 20 minutes during a production run, we are gathering 10 seconds worth of data at 10,000 hertz. So there's a lot of data being collected. Our PDX solution is doing some analytics in the background and providing us with a health measure or health index. Early in the process, we established a baseline of health with about 3 weeks worth of data. And so what you're seeing is with all of the different factors, how we are deviating from that baseline of health. And we're very early in our journey, but you know, the things that we're seeing is we're trying to better understand what does the data really mean out on the shop floor. And so the process is really generating a lot of conversations between our maintenance team, our operations team, and Roman and myself. As you know, we see some kind of change in the data. We're asking a lot of, you know, what did you see? Did you see what I just saw? What does it really mean? And, you know, as ever important, let's go out and take a look and see if it's showing what we're seeing in the data is showing up on the shop floor, and what we're seeing on the shop floor is showing up in the data. So we've got a good picture of health over time, and we monitor that on a regular basis. And what you see in the lower part of the contribution plot, as a data point is established, there are various factors that are contributing to that difference from the baseline. And depending on what frequency range it is, and which axis and at which point. So we've highlighted you see the 1 point in yellow that's out slightly above our baseline of health. And again, it's an opportunity where we've established some good dialogue of, do we really understand what's going on with the machine, and are there things that we need to do to bring our health back into check closer to that baseline? So jumping onto the next slide, you know, really from it's been a good project, and it's been a good learning experience. You know, what we recognized is that we really need to make sure we understand our process well before we start creating that digital twin of the process. So there was a lot of good trial and error back and forth before we established the key things that we needed to do. And as Roman, you know, alluded to, our decision on vibration sensors was key to the success. A couple of things that we wanted to make sure that we did, we wanted to use what we already had, whether it was the data that was coming out of our PLC or what was already provided by the piece of equipment. We wanted to work with a partner through PDX that was helping us use what we already had, as opposed to a rip and replace approach. And then we recognize that from an infrastructure standpoint, there were some key areas where the connectivity, we needed to work through some details. And so getting a good assessment of what we could do and what we couldn't do with the infrastructure that we had was important, which led us to how we connected with our IT department, because that piece of keeping our IT and our OT groups connected and working together, understanding each's roles and responsibilities, that has been key. And then the last piece, I think, is really remaining true to our roadmap. There's always a desire for mission creep to, want to expand further, faster before we're ready, or to, see if we can get more out of what we've already accomplished. We recognize that we really needed to take the time on the front end and understand the data before we started making assumptions on what we saw in the machine health. So with that, I think we're ready to jump into any questions.
Thank you. Thank you, Steve. Thank you, John. Thank you, Roman, for your insights. And for any of the audience members, I know a few questions already came through the Q&A, but this is a good time to drop in your questions through the Q&A. But John, I think I actually, brainstormed a few questions I'd love to run by you first, before going into the Q&A for the audience. You've mentioned a few challenges during the presentation of implementing a predictive maintenance solution. What would you say, question to you and the team, what do you think was the one key challenge, and, how did you mitigate that challenge during the project?
I think one of the biggest challenges was managing expectations and our understanding of the process. As a team, we've got a lot of good experience with manufacturing, but maybe not as strong in the world of vibration data. We got good support from our partners, but again, managing the expectations of what can we accomplish with this, and what does the data really mean.
A quick question actually came through the chat. You mentioned IT-OT convergence and the bond between IT and OT. What was a key challenge in that IT-OT convergence, and how did you overcome it?
I think one of the key challenges there is, OT data looks a lot like IT data, but they are very different. And the network and the infrastructure from an OT perspective is very, very similar to what IT has. And so, sometimes I think we would find ourselves kind of in the same lane of travel, wanting to make sure that we had the bandwidth to support the amount of data that was traveling, to make sure that we had all of the right pieces connected, that we had the right security. So there were times when, I think one of the things that Roman did very well was we met on a weekly basis and continue to meet on a weekly basis with our IT team to talk about where we're at, where are our next steps, and where we're going.
Thanks, John. So to the second question, which actually relates to one of the audience questions, one of the audience members asked, can you give an example of a success, something you've detected and validated? And I think it might relate to the second question, was there an aha moment during this project?
There was. It was kind of a neat opportunity. Roman and I have spent a lot of time, I should say Roman really spent a lot of time looking at the data. And there was a situation with the machine where we had a loose bolt. And so the team came back to us and said, hey, we had this event. Were you able to see it in the data? And so with some data scrubbing of, just looking through and trying to see where the correlations were and where the pattern was, we were able to see a change, not only in the health, but we could kind of identify in what frequency range that was occurring and what that really meant. So it was kind of it was a neat emotional moment. Like, yes, we're starting to see that the digital twin is starting to look like the machine in operation.
Thank you, John. So before going into, more questions, if if you could do one thing differently, MacLean team, what would it be, and how would you do it differently?
I think the one area that we would probably do a little bit differently, uh, where we've gotten good support and good understanding on the predictive side. I think understanding understanding the vibration data is probably an area where we're not as strong, and so we're taking the time now, which I think is good, to stare at the data, see what it's really telling us. But I think having a better understanding of vibration data and what it really means, I think would be helpful to us. It would have been helpful to us more on the front end.
Thank you. Thank you so much. Again, a big thank you to the MacLean team, and quite a few questions came through the Q&A, and we'll do what we can to address them today. I think this is a good question. So we talked a lot about vibration, and maybe we did not discuss it in detail during the presentation. But one of the questions is, besides vibration, there are many other measurements you might want to add, right? So can you talk maybe to the type of controller data that was being captured, and was it useful for the analysis?
Yes, I think one of the areas that we've identified is that since there are a number of bearing points where temperature might be a factor, plus within the Hadaber there are several. There's a cooling system to cool the dies, and so maybe gathering some data around that, I think, would be helpful also.
But
Thanks.
also on top of that, to kind of address the other side of what are we already collecting. We're looking at amp drop from the main motor, bar temperature, tonnage going through the machine, and we're also actually tracking within Predictronics some of the inputs to kind of help us see how they correlate. Stroke or cutoff length, stroke rate. So there are a number of other things that we are still also capturing from the PLC that are being fed into the health model. But to John's point, there's still more areas that we can try and observe.
Thank you, Roman. And if I shift focus quickly to David Siegel, question about the product maybe. So are you using other types of data than sensor data in the predictive maintenance solution? Obviously that was just addressed by Roman, but is there also a role for historical asset data in this project or other projects, David?
Right, that's an excellent question. So for this particular project, we're making use of the additional sensing data that we added to the machine, such as vibration, as well as the controller data that Roman was alluding to, such as tonnage or the amp draw and so on. We do have as part of our roadmap to incorporate maintenance record analytic or some of the historical data about what was performed on the asset in terms of repairs and things of that nature. But for this particular project and this use case for predictive maintenance, we're making use of the sensor data as well as the controller data and trying to compare those patterns over time. That's the current approach.
Thank you. I think another general question came through, Steve, John, and Roman, the MacLean team. Just in general, how long was the journey for this project? What was the duration, and what was the bottleneck maybe to get the project done quicker?
The journey has probably been really about a year plus. I think everybody can appreciate that the past year has had some time challenges to it, and with some of the challenges of the current operating environment, some making sure that we were balancing the needs of our production against the ability to kind of break in, stop, do some light maintenance, do some the implementation of the sensors. But overall, about a year to get us to the point where we were starting to see data and be able to apply that data.
Thank you, John. So this one maybe is for David Siegel, and the MacLean team is welcome to comment on this, but a few questions came through around predictions. So, we showed the health assessment and data collection and, anomaly detection when things drift into warning and all that. Is there any capability here or planned capability to start predicting actual failures and calculating the remaining useful life of the asset?
Yeah, that is part of perhaps maybe an extension to the current solution. So within our software, we have kind of a time series prediction module that can be configured that would use the past and current trends of the health index that we're calculating to kind of forecast with some confidence bounds on the future health condition of the machine as well as the remaining useful life. That's usually the first approach that we consider. As you start accumulating more and more historical data, there are more opportunities to incorporate some machine learning or pattern recognition to identify similar trends that you've seen in the past and use that information to make a prediction on the future health and life of the asset. But we're probably going to start out with the time series prediction first. As we gather more and more data. The system's been deployed probably for a few months now, so we're going to likely incorporate that maybe in the near future, moving shortly, and then as we see how that works, we may eventually incorporate more of a machine learning approach later on.
Thank you, David. So MacLean team, a few questions came through about the return on investment, which was, I think, verbalized a few times throughout the deck. But Steve, John, and Roman, how did you calculate ROI for this project? Was it just based on downtime mitigation, or if you have some thoughts about the ROI calculation, that would be very beneficial.
Sure. For the project, we were looking at a couple of areas. One was not just the cost of repairing the equipment, but also the cost of the lost time, if we lost time off of this asset, since it is a single point asset. And then we were also looking at, because I saw there was a question in here about tool life. Tool life is another area that we're going to be exploring with this deployment. So the combination of those three things and being able to improve our OEE were the key factors that played into the return.
Thank you so much. So shifting from the technology, and we talked about ROI, shifting more to the usability of the software, and back to the topic of the presentation, a day in the life of a predictive maintenance team. We have a general manager, CI, manufacturing engineering. So some questions here combined. What processes did you employ to change the culture and gain acceptance of the new technology? And it kind of goes hand in hand with, did you assign somebody to review the data daily, weekly? Did you set alerts, notifications? Would you please comment on the culture and kind of the usability of the software?
I think from a usability standpoint, I'll defer a little bit to Roman on that one, because he is primarily assigned at looking at the data. We have set some alerts so that if a data point is trending out, there are several of us within the CI team and the operations team that are getting notifications.
Mm-hmm. Yeah, that's correct. Once again, we're pulling multiple data. I'm looking at it daily. And Predictronics does a good job of showing a number of features. I think I saw a question in there about how many features are we gathering. I alluded to some of them between motor amp draw and tonnage and bar temperature, but just for the vibration sensors themselves, I want to say we're gathering probably about 400, 500 different features, but not all of them are feeding directly into the health plot. But they're the ones that have identified a lot of those, and then I have been keeping up, and to John's point that he's talked about earlier, looking through the data and seeing, okay, I see this. I might see a slight change here from today versus yesterday. What does that mean? And do we need to go look at it? And if we do go look at it, and if we find something, then we document it to try and look for it in the future within the system. So to John, or to also the question about notifications, yes, we are getting notifications. There is actually a plan to expand on the notifications, because right now we're just getting notifications on the health plot. But through more analysis and all that, we can actually set up notifications based on specific features as well.
This is Steve. I would just add it from a general manager's perspective. I think we're still gaining confidence. It's fair to say that operations people speak a different language than you guys speak. I'm sitting here listening. Hell, I don't know what you're saying half the time, but and I think conceptually everybody understands the intent of Predictronics, and we all want to make sure we're seeing a problem coming and avoiding a major problem. We're still early enough into it that we haven't gained full confidence yet. I think it's growing every week, every day. But culturally, as you've talked about, Mo, I assume that's a process you've seen in other companies as well. Mo?
It is, Steve. Absolutely. No, we appreciate your insights. It's definitely a journey, and we like the fact that you started with your manufacturing 4.0 roadmap and strategy, and predictive maintenance is part of that. So definitely keeping the technology in mind, but also the ROI and the culture and the usability of the solution. Technology, process, people, as we all say, and that's a combination for success. So I think there is maybe one concluding question for David Siegel, and maybe a concluding question for the MacLean team. And again, thank you guys for bearing with us. There's really quite a lot of questions that came through. So thank you everybody who asked the questions. This one's a bit more technical, David. It's a good question. So the MacLean team is using triaxial sensors. There is 4 areas on the machine, 20 kilohertz sampling. That's a lot of data. So the question is, how are we archiving that data, and are we really saving all that data, and how are we cleaning that data? Maybe you can give some insights into that.
Yeah, those are very good questions. Maybe I'll first go into the data cleaning aspect. So with every application that we've worked in more manufacturing or industrial applications of predictive maintenance, there always is some pre-processing or data cleaning necessary. So they can include, for example, ensuring that the data that we're collecting is from a strokes per minute that's representative of the part that we're monitoring, or the tonnage is in a reasonable range. So there are some checks to ensure that during the data collection phase, the data is meaningful for further analysis. That is part of the analysis routine in this particular project. And we are working together with the MacLean-Fogg team on a data retention policy. Right now, we are storing all the data currently, but there is a plan to have some data retention policy to archive it every few months, and that'll help mitigate the data storage challenges that would be represented with the 4 channels and the high frequency vibration data that we're collecting.
Thank you, David. So to the MacLean team, there's actually 2 questions. One is technical, and one is maybe a concluding question. On the technical side, we are looking at 4 critical areas of the machine today, right? So the question is, how did we identify those 4 critical areas? And are there other areas, like there's a question about the die, the die wear and the impact of the die, if there is a die, on the machine. So how were those 4 areas selected, and are there other critical areas on the M50 worth monitoring?
So once again, for those 4 critical areas, the drivetrain area in general is where, we've seen some of those critical failures that we've had in the past. And that's also where downtime is the most lengthy. So once again, with the conversations that we've had with the builder, Hadaber, and then also some of the outside technicians we work very closely with, we've had a number of discussions on where we want to focus on. A lot of the areas happened on the shafts within the drivetrain. So we wanted to focus on the bearing caps for the shafts, and then which ones make the most sense. Because once again, having 4 triaxial accelerometers, where would it make sense to put them? And so we wanted to try and capture as much or all the drivetrain as we could within the one implementation. And so that's how we kind of decided on where they went.
From a die wear standpoint, so as part of our cadence, our engineering team and our operations team and tool making team meet on a weekly basis and talk about what were the events of the week, tool wear related, maintenance related. And our hope is that as this evolves, we'll be able to take some of the data that we see here. This part very specifically shows this type of impact on the equipment. And therefore, is this something that we can look at from a tool design standpoint? How can we make this tool run much easier on the machine?
Thank you for sharing that. So as kind of a parting question with the MacLean team, and again, really thank you for your time and insights and experience. A day in the life of a predictive maintenance team. So manufacturing engineering, continuous improvement, operations management, right? We have 3 key roles here. In your role, any parting words or advice you may have for somebody else in another manufacturing company that is trying to do this today, that is, who's embarking on a predictive maintenance journey? Maybe Roman, we can start with you if you have any advice for somebody in your role in a different company.
Yeah, a couple of words of advice. Once again, when we started this, I didn't have the greatest knowledge within vibrations. So reading up, finding articles, asking the Predictronics team for some help there. But I think the biggest thing is, make sure to plan to give yourself some time to go through the data. We're still early in this, but, as I keep staring at it day after day, I'm finally starting to understand, okay, I'm seeing this is going here. Or, if we've had an event, okay, this is where I'm seeing that. And then how can we work with the system and, set up the notifications more discreetly for events as time goes on. So it's give yourself the time to go over the data and try to understand what it's telling you.
Thank you, Roman. John, any parting words of advice?
I think the relationships are key. Relationships within the organization, making sure that the team stays together, and then relationships externally with your support partners.
I would just add one thought too, Mo, and I think it's critical that you have a guy like Roman that has the aptitude and the passion, for analyzing data and understanding. And I use this in a complimentary way. There's a bit of a geek, in terms of diving into this, understanding and helping the rest of us understand it in layman's terms. And then having a guy like John as the lead, who's got a manufacturing engineering background, but also has some IT background, and then trying to engage our operations people and make sure they're comfortable with what they're seeing, they're buying into what we're doing. It really has been a team effort, and we're on the journey still, but I'm pleased with where we're at.
Thank you. Thank you very much. I think this concludes our webinar today. Special thanks to the MacLean team. Thank you, Roman. Thank you, John. Thank you, Steve. Special thanks to Dr. Siegel, Predictronics team. Please contact us. Let's stay in touch. We'll be emailing the audience the presentation and the recording. And again, special thanks to the MacLean-Fogg team. Thank you and have a great day.